Alright guys, welcome to Math 0106, Lesson 7. Today we're going to be talking about least common multiples. And there are two ways of approaching least common multiples. So the question here that we're looking at is, what are the least common multiples of 20 and 30? So I'm going to write this off to the side here. The first thing we need to understand is that what is the least common multiple? Least common multiple, or the LCM. And a multiple, we said, is essentially a number multiplied by the natural number. So, for example, the multiples of 2 would be 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. When we're saying we're looking for the least common multiple, what we're doing is we're trying to find the smallest multiple of both numbers that they share in common. So, for example, multiples of 20 would be 20, because 20 times 1 is 20, 20 times 2 is 40, 20 times 3 is 60, then 80, then 100. And another way of thinking of this is I'm just adding 20 every single time. Okay? So one way we could find the LCM, and we could do the same thing with 30. So 30 times 1 is 30, 30 times 2 is 60, 30 times 3 is 90, and I could keep going if I wanted to. I'm not going to write them all out. So one way of finding the LCM is to list. And when you list, the nice thing about listing is you get to see everything. So we can very quickly see that at 60, these two match up, and there's my LCM. And so one way of doing this, again, is to list. Another way of doing this is to write 20 and 30, and to break it down to its prime, both these numbers to their prime factorizations. So if we do that, we see we're left with 2 squared times 5 and 2 times 3 times 5. And this is the part that's a little tricky when you first see it. You're going to take only the highest power of each. So when I'm looking at 2 and 2 squared, the highest power is 2 squared, so I only take that. Then I see 3, and 3 is just by itself. There's over on the left-hand side, we don't have a 3. So here we're just going to use the 3. And these both are 5, so we're going to use 1, 5. So what we're left with is 2 squared times 3 times 5, which leaves you with 4 times 3 times 5. And I think the easiest way to multiply this is 4 times 5 is 20, 20 times 3 is 60. And that's the LCM. And if you think about it, it makes sense, because what we're doing is we're taking the most of each base, right? That's what the least common multiple would be. It's the most that everything has in common, but nothing more. So, in other words, you wouldn't multiply by another 2, because that would work, but that wouldn't be the least. That would be a multiple, but it wouldn't be the least multiple. So by taking the highest each one has, you're taking what each one has, and that would be the least common multiple. Now, these are the two ways that the notes describe it. They give these two methods. Now, there's another way of doing this, and I actually really do recommend doing it this way, if you can. There are advantages and disadvantages to both. So what I would do is take the higher of the two numbers and start listing multiples. So the multiples of 30 would be 30, and when you write out each one, just ask yourself, is 20 go into 30 evenly? No. So the next one would be 60. Does 20 go into 60 evenly? Yes. There's your LCM. And it's as easy as that. And I think that is if you're going to list, if you're going to use this method here, I would just take the higher number and see if the other one divides into it. And that was how I would find the LCM. Now, what you're going to find as we work through these is that on certain problems, one method is superior to the other. So my advice to you is initially try the third method, try the tertiary method, this one that I did in orange. Try to use that. If it works, great. If it starts to get a little tedious, then you want to shift to prime factorization. In general, when you use this technique, the third way I showed you is probably the most effective in sort of like a real-world setting. So let's go ahead and try another one. Let's try number 2, 4 and 6. So I'm going to use the third method because I said it's the best one. So I'm going to take this number 6. I'm going to just start writing multiples of 6 and asking myself, can 4 go into it? So does 4 go into 6? No. The next multiple of 6 is 6 times 2, which is 12. Does 4 go into 12? Yes. And there's your answer. It's as easy as that. Okay. Let's look at number 3, 8 and 12. So we're going to start with 12, and we're going to ask ourselves, does 8 go into 12? No. The next multiple of 12 is 24. Does 8 go into 24? Yes. 8 times 3 is 24. There's your least common multiple. Next one. I promise you that it does seem pretty easy right now, but it will get harder. 12 and 20. So we're going to take 20. We're going to say, does 12 go into 20 evenly? No. The next one is 40. Does 12 go into 40 evenly? No. By the way, with 12, you do know what times what is 12, even if you don't have it memorized, because a lot of the 12 is synonymous with a clock, so you know half a day is 12 hours, one day is 24 hours. You may not know a day and a half is 36, but 2 days 48. These are pretty common numbers. So the next one would be 20 times 3, which is 60, and 12 does go into 60. If you're not for certain, we can use some of the techniques that we learned in the previous section. So, for example, 60 is 6 times 10. I'm just literally 6 and 10 was the first thing that popped into my mind, and 12 is 6 times 2. And then you can see the 6 does divide out, and this would divide and give you 5, so it does work evenly. And 60 is the LCM. So you can see that this listing method is pretty fast and pretty useful. Next one, number 5, is 5 and 7. Now, I can tell you, I'm going to, for consistency, I'll list, but I can tell you that the LCM here is going to be 5 times 7, which is 35, because both of these are prime numbers, right? So it makes sense. I mean, even if you were using the prime factorization method, right? I mean, you're just 1 and 5, 1 and 7. We're not even going to consider 1, so you know it has to be 5 times 7. So if you understand what LCM really implies, then obviously if you have two prime numbers, the LCM is going to be the product of the two. So keep that in mind as well. Let's look at number 6, 11 and 13. So again, 11 and 13 are prime, so I'm just going to do 11 times 13. And hopefully you recall that rule that I told you with 11s, where you can take 1, you take this 1, you put it here, you take this 3, you put it here, and the middle is 1 plus 3, which is 4, so it's 143. And that would be your LCM. Number 7. So again, I want to reiterate for number 6. I just jumped straight to that method because both 11 and 13 are prime. So also want to stress here, what's really neat to see is that every technique that we've learned is something that is we're going to build upon. So we learned what a prime number is. Now we're building upon primes. So it's very important that you keep up to date with everything. Let's look at 2 and 3. So again, 2 and 3 are prime. So the answer is going to be 2 times 3, which is 6. That's it. Notice that this is a method. This is not the only method, but I'm just trying to. It would take me forever to work through the problem doing it in multiple methods. So what I'm doing here is I'm showing you the methods that I would use in each scenario, how I would approach it, and you're going to see as we progress, I will eventually start using other methods instead of the default method. But for the time being, these sort of method is what I'm doing right now. Of just listing the highest one seems to be the most effective, so we'll continue to do that. The next one's 4, 10, and 15. Now these are not all prime, so multiplying them all together won't be a good idea. I'm going to again take the highest one, and I'm going to say, hey, does 4 and 10, so now we have two numbers, so we have to test both of them. Does 4 and 10, has to be both, go into 15? No. So the next multiple would be 15 times 2, which is 30. Now, 10 does go into 30, but 4 does not go in. So the next one would be 45. That's not going to work. In fact, at this point, I can do multiples of 30, and hopefully it's clear why, because if the 10 has a 0, it's going to have to be that. So the next one would be 60. 10 goes into 60, and you actually know that 4 goes into 60 as well. Think of a clock. right? Every 15 minutes on a clock has 60 minutes total. So you know 15 goes in there 4 times. So there's our LCM. So you can see also that as we work through these problems, I'm a big proponent of trying to use the real world to give me an inkling as to what method I want to, or how to solve problems. So where do we got? Number 9. Sorry. I was trying to do 2 things at once and it wasn't working out very well. So with 10, let's see here. So let's list. So 10 would be first 10. 6 and 8 do not go into 10. Next would be 20. That's not going to work. Next would be 30. 6 goes into 30, but 8 doesn't. Next would be 40. 8 goes into 40, but 6 doesn't. Next would be 50. Neither. 60. 60 works with 6, but it doesn't work with 8. 70. No. 80. So you can see that I'm exhausting. I've been doing this 8 times and not getting to the answer. So at this point, I'm going to jump to prime factorization. And when I write the prime factors, I'm going to get 2 and 3. Now, this is going to be 2 and 4, which breaks down to 2, 2, and 2. And knowing that 8 is 2 cubed, as you progress in math courses, you're going to find that to be incredibly useful. So I would make a little note to myself to make sure that I realize that 2 to the third is 8. Okay, so I've listed them, and now I'm going to take the highest power of each. So 2, I have 2, 2 to the third, and 2, so I'm going to take 2 to the third. I only have 1 3, so times 3, and I only have 1 5, so times 5. So this is going to be 8 times 3 times 5. Now again, I want to encourage you that when you have to multiply through, look for the easiest combination. So I have 8 and 5 is 40. 40 times 3 is 120. And that's your LCM. And you can see that I'd have to keep doing this a couple more times in order to see it. So my advice to you is use that third method of just taking the highest number and writing out the multiples and seeing if the other ones go in. And after something like this, I mean, you decide for yourself when it's becoming intolerable to keep guessing and checking. If it becomes difficult, then you will go ahead and break it down to the prime factorization. Okay, let's see the next one. So that was number 9, number 10, 12, 20, and 30. 10, 12, 20, and 30. So again, what I'm going to do is I'm going to take the highest number, which is 30. I'm going to ask myself, does 12 go into 30? It does not. So I'm going to list the next multiple of 30, which is 60. Does 12 go into 60? It does. Does 20 go into 60? It does. There's my LCM. Let's look at number 11. 8, 12, 20. Again, take the highest number. Ask yourself, does 8 go into 20? It does not. So the next multiple will be 20 times 2, which is 40. Does 8 go into 40? It does. But does 12 go into 40? No, it does not. So the next one would be 60, which is 20 times 3. Does 8 go into 60? It does not. By the way, if you're not certain, you can take the number and you, again, write it as, break it down to factors and check. So we can see here that this would give me 2 left on the bottom, 3 here. And this would leave me with 5, and it would leave me with 15 over 2. So it doesn't go in evenly. So 60 doesn't work. Well, what about 80? Well, 8 goes into 80, but what about 12? Well, I'm not certain. Let me check. So we'll do 80 divided by 12, which I'm going to say is 8 times 10. And 12, I'm going to say, is 4 times 3. And so you can see because of the 3, it's not going to work. So then we can go to the next one. Or at this point, it makes sense to try prime factorization. So earlier I told you that 2 cubed is 8, and you should try to memorize that. So I'm just going to write it as 2 cubed. 12 we know is 3 times 4. I literally just wrote that here. And 4 breaks down to 2. Times 2. So we have 2 squared times 3. 20 is 2 times 10, which breaks down to 2 times 5. So this is 2 squared times 5. So now we take the highest power of 2's. So notice that both of these are 2 squared. Frequency doesn't matter, it's the highest. So we're going to take 2 cubed times, we only have 1 3, and we only have 1 5. And so this is going to be 8 times 3 times 5. And again, when I do this, I'm going to look for the easiest combination. So I think 8 times 5 is 40, times 3 is 120. And there's our answer. I do believe, by the way, the last time we did this, yeah, it was the same thing. Huh. Okay, so let's see what the next one was. So that was number 11. So number 12 is 5, 7, and 11. And again, because 5, 7, and 11 are all prime, the answer is going to be 5 times 7 times 11. So, like, just to be clear here, if I did write it in terms of the prime factorizations, we don't include 1, but I'm going to write it with 1. So we take the highest of each, which would just be 5, 7, 11. I mean, you technically could even include 1, but 1 times anything is just the anything, so it doesn't really matter. So this is going to be 5 times 7 times 11, which is 35 times 11, which is 5, 3, 5, 3. So 5, 8, 385. And there's your answer. Okay, so if I give you 2, 3, and 5, again, these are all prime, so I can just say it's 2 times 3 times 5 is my answer, which is just going to be 6 times 5. That is an ugly looking 5. Let me make it look pretty. Yay, now it's pretty. So 6 times 5 is 30, and we're done. Okay, what's the next one? 14, 7, 13, 91. 7, 13, 91. Now, when I look at this, I have to make the decision. Obviously, I can clearly see that 7 and 13 are prime. Let's say I don't know about 91 though. So one thing that makes sense to do is to try to use these numbers to see if they go into 91. But let me explain why I'm going to do that. So the very first thing you should do if you don't know if a number is prime is try to use the rules that we've discussed at the very first lesson. So you ask yourself, hey, is the number divisible by 2? So does it end in a 0, 2, 4, 6, or 8? No. Then you say, okay, is it divisible by 3? Well, if I add 9 and 1, I get 10. Is 10 divisible by 3? No. Then we say, is it divisible by 5? Does it end in 0 and 5? No. Is it divisible by 6? Well, it needs to be divisible by 2 and 3. It is not, so no. Is it divisible by 9, which means you add up the digits and see if the sum is divisible by 9. Well, if it doesn't work with 3, it's not going to work with 9. So you want to exhaust your divisibility rules first. It's a good little litmus test to see if anything works. Really, if you check for 2, 3, and 5, and none of those work, you're pretty much you are for certain that the divisibility rules do not work. Okay, so I've exhausted those. So once you've exhausted those rules, it doesn't mean that the number isn't divisible by something. 91 could be divisible by 7, for example. It could be divisible by 13. It could be divisible by 11. Who knows? And that's where it's a little difficult to tell. And as numbers get bigger and bigger, it becomes harder and harder to tell. But it does make sense to try to use the numbers given. So I'm just going to divide 91 by 7. And this is going to give me, look at that, 13. So 91 is 7 times 13, which means what? It means 91 is the LCM. Okay, so now let's test 2, 5, and 10, number 15. Well, here it's very similar to the last one. We know 2 times 5 is 10, so the LCM has to be 10. So you use that. Okay, let's try 16. See if we can fit it in here with 16. 16 is 6, 12, and 18. 6, 12, and 18. So here, you know that 6 goes into 12 and 18. So the only question that you really need to concern yourself is when does 12 go into 18? So let's start listing multiples of 18. So 18 is 18 times, the first multiple obviously is 18. Does 12 go into 18? No. 18 times 2 is 36. Does 12 go into 36? Well, we remember in our conversation about time, 1.5 days is 36 hours. So if that's true, then 12 would fit in there. And so there's your LCM. So one interesting aspect about this sort of problem is because I know 6 goes into 12 and goes into 18, I don't have to worry about 6. Because if it works with 12, if 6 goes into 12 and 18, it's going to work with both of these no matter how big the number is. So what I'm saying is 12 is 2 times 6. So you know that it'll work. So if you're talking about 12 times 2, then 6 will always go in because there's a factor of 6 inside of 12 that'll always divide out. Okay, so hopefully that makes sense. Let's look at 17. 17, 20, 50, and 45. 20, 50, and 45. 20, 50, and 45. Now, here, what I'm going to do is I'm going to jump straight into prime factorization. Because as numbers get bigger and bigger, 50 and 45, they're pretty close to each other. I can tell that the LCM is going to be a pretty large number. So if you have big numbers and the numbers are close, like for example, if I had 60 and 59, probably the best option at that point is to just do prime factorization, because if they're very close, it's going to take a very long time before you find the LCM by listing. So let's break these down. Remember, as I break this down, how you break this down versus how I break this down may not match up, and I encourage you to do it a different way and see if your prime factorization matches up with mine. And so you can see here that with 20, I could do 2 and 10 as I did, but I could have also done 4 and 5, right? And it would work either way. Same thing with 50. I could have done 2 and 25. I could have been thinking about quarters, and it still would have broken down to the same way. So you pick what pops in your mind, and I'll be honest, like right now I'm doing this, and these are the combinations that pop in my mind. I may do this problem later on, and I pick a different combination, okay? But once I've done this, remember this prime factorization method, we're going to take the highest power of each. So students of 2 squared and 2, we're going to take the highest power, which is 2 squared. Then we have 3 squared, only one 3 squared, so we'll say 3 squared. And then we have 5 squared, and 5, so we take the highest, which is 5 squared. And from here, we just multiply these out. And so this is going to give me 4, this is going to give me 9, this is going to give me 25. Be careful. It's very easy to say 3 squared is 6 or 5 squared is 10. So just be careful, watch yourself. And then at the very end, we're going to look for the easiest way to do this. 4 times 25 is 100. 100 times 9 is 900. And there's your LCM. So you can see that had we listed 50, you'd have gone to 900, which is a pretty long, good chunk of time before we would get there. So if the numbers are big and they're close together, it's probably best to do the LCM. I'm sorry, well, that's what we're doing. It's probably best to use prime factorization to find the LCM. Okay, so next we have 98, 50, and 40. 98, 50, and 40. 98, 50, and 40. And again, because these numbers are so close, it makes sense for us to break these down to the primes. So we'll take each of these separately and let's break them down to primes. Now, when I do 98, recall that we know 100 divided by 2 is 50. I think that's pretty common knowledge. So if I drop 1 down, if I drop 2 down, rather, it makes sense that it's just the same thing as dropping down 1 to 49. Another way of thinking about this is if 100 divided by 2 is 50, then 100 minus 2, if I divide both of these by 2, would be 50 minus 1, which is 49. So these are little techniques that help you to figure out what numbers are without having to jump to a calculator. I encourage you to know those skills, learn those skills. And again, even if you're like doing this during you're doing this class online, or you're just watching these videos just for your own enrichment, and you're gravitating towards the calculator, I would encourage you not to, because these are skills that if your goal is to progress in college level material, you need to be able to know that 98 divided by 2 is 49, and it should not take you that much time. If you have to gravitate towards machines to do stuff like that, in the grand schemes, there's basic skills you're losing along the way that make it impossible to do higher level math. So you're really hurting yourself in the grand scheme of things. Now, with 50, I'm thinking 5 times 10, and then 2 times 5. And with 40, I'm thinking 5 times 8, and 8 is infamous at this point. You should be thinking 2 times 2 times 2, 3 times. So this breaks down to 2 times 7 squared. This breaks down to 2 times 5 squared, and this is going to be 2 cubed times 5. Again, remember, what we do is we take the highest power of each. So I have 2, 2, and 2 cubed. The highest power is 2 cubed. Next up, we have 5 and 5 squared. I'll take 5 squared. And then all by its lonesome, we have 7 squared, so 7 squared. So this breaks down to 8 times 25 times 49. And when I look at 8 times 25, I think of quarters. So if 4 quarters gives me $1, then 8 quarters would be $2. So this would be 200 times 49. Now 200 times 49 is easy because we just said right here, 49 is 98 divided by 2. So you can see that 2 times 49 would give me 98. So this is going to be 2 times 49 is 98. Because I have 2 zeros, I literally can just tack on the 2 zeros, and the LCM is 9,800. And you can see here, right, like, list, I guess, sorry, I should be going with 98. I'd have to list 10, quite a few, let me put it this way, I'd listed quite a few number of multiples of 98 to get there. And multiplying by 98 is not fun. So as the numbers get bigger, prime factorization definitely becomes the weapon to use. Okay, 2 more. And this one I can actually do right here. 4, 9, and 36, because 4 and 9 are both go into 36, the LCM is 36. Easy enough. Number 20, 12, 75, and 100. Let's write that out. 12, 75, and 100. And you know what? I keep writing them and then just rewriting them, so I'm just going to do that once. Again, these are numbers. I probably could do the listing, but 75 is a little tricky, and factors of 12 after a point get a little bit difficult to do off the top of your head. So let's just do prime factorization. This is 3 and 4, 2 and 2, 75 3 quarters, 75 cents, 100, 2 and 50, 2 and 25. And I'll be honest, a lot of times, if you catch me just not really wanting to think much, if I know it's even, I'll just keep dividing by 2, like I did with the 100. Okay, so hopefully this all makes sense. And now what we're going to do is we're going to say, look at the factors of 2. So these are both 2 squared. So it'll be 2 squared, 3 and 3. Now, just because they're the same, I'm not writing them down because they're the same. I'm writing them down because the highest power is what they are, right? And then the last one is going to be 5 squared, 5 squared. So here we have 5 squared. So this breaks down to 4 times 3 times 25. 4 quarters makes $1, so this is 100 times 3 is 300. And this is why I was saying you could probably list it, because I knew it was 300, but I didn't want to write them out. In any case, there you have it. Big thing I want you to realize is that we're at the point in this course that you really are going to want to practice these ideas. So hopefully you were pausing the video and trying these throughout. But if you struggled through this, my advice now is to put everything away and see if you can do this without looking at anything. In any case, we're at the end of this video, and I'll catch you in the next one.